The next identification number we'll talk about is the ISBN 10 number, a number many of you are probably quite familiar with seeing. The ISBN 10 number is a 10-digit number. The last one is the check digit, and it's chosen so that 10 of the first, plus 9 of the second, 8 of the third, 7 of the fourth, 6 of the fifth, 5 of the sixth, 4 of the seventh, 3 of the eighth, 2 of the ninth, and 1 of the 10th is divisible by 11. So right here, this is our first divisible or division by 11 scheme. Now, it'll also be our only one. The ISBN 10 detects many errors. It detects all transpositions. So that we've discussed, it detects single position errors. It also detects adjacent digit transpositions. So if you write a 3-4 instead of a 4-3. It also detects any jump transposition. So the bank number method detected a jump transposition where you wrote like 215 as 512. So if you took a block of 3 and flipped it around, the bank digit would detect that. This ISBN will detect any of those transpositions. So if you just somehow flip the first and the 8th digit, this will detect that something went wrong. If you flip the first and the second, it'll detect something went wrong. And it's a very nice identification number with good coding. Now there is one issue, and I guess I'll explain the issue right now. One issue with this is that this check digit could be 10. And if the check digit is 10, well then that makes this an 11-digit number. Now, the way, according to the textbook, the way places get around that is if the check digit comes out to be a 10, they'll just write it as an X. The textbook implied that there aren't that many products like that with an ISBN 10 where the 10 is written as an X. If you can find one, I would be quite happy to see that. But let's find a check digit for an ISBN 10 number. Example, find the check digit. 2, 3, 0, 4, 7, 6, 2, 1, 5X. Find the check digit. Now to find this, we do 10 of the first, 9 of the second, 8 of the third, and so on. So let's write that all out. 10 of the first is 20. 9 of the second is 27. 8 of the third is 0. 7 of the fourth is 28. 6 of the next number, 6 times 7, 42. 10, 9, 8, 7, 6. 5 of the next one is 30. 4 of the next one is 8. 3 of the next one is 3. 2 of the next one is 10. And then 1 of the last one is just X. One way you could organize this multiplication, you could do something like write a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You could write small numbers underneath that to help keep yourself organized. As I was writing those out, I was kind of visualizing them. And I'm going to use that to check. So let's see, 20, 27, 0, 28, 42, 38. I just saw this 15 times 32 and it really threw me off. 3, 10, and X. So we want this to be divisible by 11. Well, let's add all these together. 47 plus 28. Those first two together makes 47. These next two together make 70. So I'm just going to add them like that. Plus 30 plus 11 plus 10 is 21. Plus X, we want that to end in an 11. Well, 70 plus 30 is 100. So right here we have 147 plus 21 plus X. We want that to be divisible by 11. And when you're adding, you don't have to stay in the proper order. You can add in whatever order you want. So we want that to end in n, or not to end in 11, to be divisible by 11. So we get what? 168 plus x is divisible by 11. Well, now we need our 11 times tables. Who knows the 11 times tables? Well, I'm the only one in this room, so I have to know them. 11, 22, and so on until you get to 110. We need to go above 110. 121, 132, 143. That's when I stop knowing the times tables, but I'll just keep adding 11 because we can do that. Why not? Until we get above that. 176 is the next one. So what will make that 176? X equals 8. So x equals 8 would give us what? A valid ISBN 10 number. Now, what if we had some other number? What if, let's do this, check if this number is a valid ISBN number. So example, check if this is a valid ISBN number. 236541907 Check if this is a valid ISBN 10 number. Well, I'm going to do that by writing out the 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1 underneath them. Because now all I have to do is multiply and go down. 20, oh, I must have started the other one with 2, 3 also. No, whatever. 20 plus 27 plus 48 plus 35 plus 24 plus 5 plus 36 plus 0 plus 14 plus 3. So this is valid if this is divisible by 11. Wow, these are inconvenient numbers. Well, whatever. First two make 47, that's 48. 59 plus this right here makes a 50, so that's nice. So these all make a 58. What did I add to get these numbers? The first two gave us 47. I left the 48 alone because 47 plus 48, I don't know, I consider that a convenient addition because it's 5 less than 100. Because it's 3 less than 50, 2 less than 50, so that's 5 less than 2 50s, which is 95. You can add in whatever order you want, whatever's most convenient. Those two I added to make 59, and these made a 50, and those made an 8, so I wrote that as a 58. So then we have to add these together. 95 plus 117, that makes 212. I should use equals sign since these are equal. I don't know if I used them before. And 212 is not divisible by 11. Why is it not divisible by 11? Well, it's not divisible by 11 because 220 is. How can we actually check that? So which is not divisible by 11 since, well, what happens if we do the division? 11 into 212. Well, 11 goes into 21 once. Subtract 11, you're left with 10 and a 2, and 11 does not go into 102 because it goes into 99, and then you have a remainder of 3. So right here, not a valid ISBN number. Now, there's the ISBN 10 number, and it does have that one drawback I mentioned where the check digit could be a 10, which could lead to a, well, it could lead to a choice that manufacturers have to make. But the ISBN 10, like the UPC code, has been extended to another number. The ISBN 13 number is a 13-digit identification number. So we'll call it A1 through A13, where A13 satisfies this equation. Well, it doesn't satisfy it. It says that that equation must be divisible by 10, meaning that number must end in A0. Now, the ISBN 13 is an extension of the ISBN 10 in the following sense. So I'm going to say equals. I'm going to put the equal sign in quotes, though, because it's not completely equal. But the ISBN 13 is 978 or 979 plus the ISBN 10. Now, why is it quotes equal sign? Well, it is 978 or 979 and then the ISBN 10, but it doesn't take the exact check digit from the ISBN 10. The ISBN 10 will have a certain check digit on it, but this will assign a new last digit. So the ISBN 13 is 978979 plus the first 9 digits of the ISBN 10, and then a final check digit. That satisfies this equation. Now, this number down here, A1, 3, A2, A3, and so on, we've seen that number before just today. We've seen this number. This weighted sum with weights of 1, 3, 1, 3, and so on for a 13-digit number was used in the extension of the UPC code, the 13-digit European code. Had this same type of formula. Now, let's just verify a check digit for something. Let's just take this book I have over here, the nearest book to me. History of Wayne County, Pennsylvania. That's where I am right now. For those of you who don't know, let's see. How do you draw Pennsylvania? There it goes like that, and over, up, out, over. That's a pretty bad drawing. I have to redraw that. That's really bad. That does a disservice to Pennsylvania. It does a disservice to the Delaware River border of Pennsylvania. So what does it do? It goes down over to Port Jervis in New York. It goes down over. There's I don't know what's over there. Trenton's on the other side. On this side, it's Bucks County. And then we have the Ark. That's close enough. Allentown, well, I guess almost none of you are probably in Allentown. Allentown is somewhere down here in Lehigh County, Pennsylvania. Wayne County is the one right up here, like that. I am up here, 3 miles from the border with New York, 3 miles from the Delaware River that way. Nice part of Pennsylvania. Well, why did I bring that up? Well, I brought that up because we have this book here with an ISBN 13 number. And what we're going to do is verify that the check digit on it is correct. To draw Pennsylvania, I should have erased the entire boards and just drawn a large Pennsylvania across all 4. But I didn't. So let's check. This says the check digit is 1. The last digit is 1. So I'm just going to say let's check the check digit. Or let's find the check digit for this. X equals 1 according to the book, and we're just going to verify that. So what do we need to do? Well, we need to do 1 of each number and then 3 of the the 3 of the even indexed numbers. So let's underline the ones that get a 3. Every other one gets a 3, starting with the second one. And then we just do 9. Plus 3 7s is 21. Plus an 8. Plus 3 1s. plus a 3, plus 3 6s, plus another 3, plus 3 1s, plus an 8, plus a 9. Geez, what did I do? Oh, that 8 isn't underlined. Okay, I just made a sort of mistake, so I have to take a step back and check what I just did. 9, 21, 8, 3, 3, 6 makes 18. 3, 3, 8. Plus 3 9s is 27, plus a 2, plus 3 8s, plus x. We want to find x so that this ends in a 0. Well, let's just add these together. 30, 38, plus 3 makes 41, plus 3 makes 44, plus 18 makes 62, plus 3 makes 65, plus 3 makes 68, plus 8 makes 76, plus 27 makes 103, plus 2 makes 105, plus 24 makes 129. Plus x must end in a 0. So we get x equals 1, which is what the book said. Now this ISBN 13 number, the ISBN 10 detected quite a bit of errors. The ISBN 13 detects all of those, but remember the one problem with the ISBN 10 was that the check digit could sometimes be a 10, which could give an 11th digit on the ISBN 10, if you don't write it as an X. Now, the ISBN 13, since this sum is going to be divisible by 10, that last digit is not going to be larger than 9. Because it's going to be either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we've covered a lot of different numbers with a lot of formulas. There will be a chart of some kind, or a graph, or a list of some kind. I haven't made it yet, so I don't know exactly what it'll look like. But on Canvas for this week, there will be something that kind of summarizes all of these identification numbers, because I do think it is a lot. And I wouldn't expect you to memorize all of these properties, but I would expect you to be able to use these rules in all of the numbers like we've gone over today. But as for memorizing them, and I'm never going to ask students to do things I wouldn't expect of myself. And I cannot, well, I can, but I think your time would be better spent doing other things for this class than memorizing a bunch of rules like this. I think rules like that are kind of hard to remember. So let me know if you have any questions. There are a good deal of numbers. Try the examples on the worksheet and see how they go.